Solving the problem 2471, minimum numbers of operations to sort a binary tree by level. So given the root of a binary tree with unique values, in each operation we want to swap two nodes at the same level, depending on their values, and then we want to record the minimum numbers of operations needed to make the values at each level sorted in a strictly increasing order. So each level, we just want to swap it based on the values. So 4 and 3, we want to swap it to 3 and 4, and then here we want to swap it to 5, 6, 7, 8, depending on these values. So the way we do this is we're gonna want a sorted numbers list based on this list right here, and then we can also map each number to the index, and then we loop through swapping like that, and we want to use binary search to our first search for each level. So we can start off with the BFS. So here we can have initialize the root for the queue, and then also have a result. So for each level, while we still have the queue, we can initialize the level, and then for each level, we want to pop and get the node, and then we also want to add that node's value to the level. So if there's a left child, we want to add that to the queue also. Also do the same thing with the right. And then we want to add to the result the amount of swaps for each level. And we're going to have a function right here, recursive function for the current swaps. And then we want to pass in the numbers list. So we want a sorted list for the numbers, and we also want to initialize the number of swaps we're going to make. And then we have an index map, mapping each number to index for each number, index and number in enumerate nums. And then we want to loop through the numbers list. And then if the current numbers value is not equal to the sorted numbers value in the sorted list, we know we need to make a swap, and we can save the index maps. The index maps sorted numbers index. So we want to store the sorted numbers index inside the index map into J, and here we make the swap. And then we want to return the amount of swaps. But before we do that, we know we need to update the index map at each index for numbers of I and nums of J. And that's it. That's how we solve this. And this is my first solved problem. It's just to help myself pass an interview in the future. So yeah. And then also the time complexity would be O log n, because for each level we need to sort each level basically. And then space complexity is O of n, because for n, where n is the a number of nodes. So let's check if I'm correct. Let's see. Yep, O of n and O of n log n. Okay, that's gonna be it for today's video.